What's going on, everybody? Welcome back to my YouTube channel. Now look at this nice and beautiful question we have here on the board that we're going to be solving together. And the question says, for all real values of x and y, 2 to the power of x equal to 3 to the power of y is equal to 216. And we are to look for 1 over x plus 1 over y. So our first step is to take what the question asks us to look for, which is 1 over x plus 1 over y. We have to make it a single fraction. And how do we do that? By taking the LCM. So what's the LCM of x and y? The LCM of x and y is actually xy. So xy divided by x is y. So y times 1 is y. Plus xy divided by y is x. X times 1 is x. So this is our first step. Take note of this expression here because it means a lot to us. So now our second step is to take 2 to the power of x and equate it to 216 because the question says they are equal. So 2 to the power of x is equal to 216. This can also be written as 2 to the power of x equal to 6 to the power of 3 because 6 to the power of 3 is 216. So let's do the same thing with this 3 to the power of y. So 3 to the power of y is also equal to 216. As we can see, they are equal. And this can also be written as 6 to power 3. And now, since this one is having a power of x, there is something we can do. We can multiply the power by y. So let's do that. So 2 to power x, I'm going to be multiplying the power by y. Equal to, since I'm multiplying the power on the left hand side by y, I should be doing the same thing to this one. So I'll be multiplying the power on the right hand side by y as well. So let's come here and do the same thing. But in this case, we have a power of y. So we're going to be multiplying this power by x instead. So since I'm multiplying the left hand side here by x, I should be multiplying the power on the right hand side by the same thing, x. Now this becomes 2 to power x times y is what? xy equal to 6 to power 3 times y is what? 3y. So this is going to give us 3 to power y times x is xy equal to 6. 3 times x is 3x. So everything is looking well and good. So our next step is for us to multiply this expression by this. That means I'm going to be multiplying this by this, multiply this by this other side. So let's go. So 2 to power xy multiply by 3 to power xy equal to this side 6 to power 3y multiplied by 6 to power 3x. So everything is looking well and good. So let's move forward and see what we have next. All right, so since this one have the same powers, that means common powers, that means I'm going to be grouping the power. So this becomes 2 to power 3. So they have a common power, so which can be written like this. Are you seeing that? Very good. So equal to, now what's something here? From indices, whenever I have a base, a raised to the power of m, multiplying another base, the same base actually, but this time raised to the power of n. The law of indices says since the bases are the same, take one of the base and add the powers. So this is what is actually happening here. This is a base of 6 and there's also a base of 6. So what happens is that they have the same base. So I'm going to be taking a base, and since I can see multiplication here just as it is here, that means I'm going to be adding the powers. So 3y plus 3x. Now, let's simplify further. So 2 times 3 is 6 raised to power xy equal to 6 to the power of 3y plus 3x. Now, notice that the base on the left is the same as the base on the right. And since the bases are the same, we can equate the powers. So let me write equate powers here. Equate power. So the power on the left is xy equal to the power on the right is 3y plus 3x. I can actually factorize 3 out because it is common here on the right. So xy is equal to 3 out, so leaving behind y plus x. So this is actually looking good. So our next step is to divide both sides by y plus x. So let's do that. So xy, I'll be dividing it by y plus x equal to 3 times y plus x actually. This is y plus x. I'm going to be dividing it by y plus x. Now notice something, that y plus x here will go, leaving behind 3, equal to xy all over y plus x. Now I want to take our mind back to something where we started from the first step. So let's go back there. All right, so actually this is what we're looking for. Are you looking at it? Very good. So this is expression reduced to a common denominator. All right. So we have y plus x all over xy. So I'm going to be making what we are solving right now to look exactly like it. Now, remember what we have is xy all over y plus x. Not actually this, but you notice that the inverse will give us this, right? Good. So now let's go back there and take the inverse. So I'm going to be taking the inverse of this expression so that I have y plus x all over xy equal to, since I took the inverse of the left hand side, I'm going to be taking the inverse of the right hand side as well to balance everything up. So the inverse of 3 is 1 all over 3. Voila, this becomes our final answer. Well, I hope you enjoyed this video, and if you did, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.